Normalization is the process of structuring a relational database based on a sequence of rules called normal forms. Database normalization divides large tables into smaller ones and links them by creating relationships. It defines the structure of a database with columns and tables. Without further details, let's go to the demo. Welcome everyone. Today we will learn how to normalize a database in the third normal form and how to detect anomalies when a database has no normalization. This demo is created in a simple Microsoft SQL Server playground, which we will run the following query to create a customer table with the following properties. Insert two values in the customer table and select all the rows from the customer. Run the query. This database is denormalized. We can detect three anomalies. The first anomaly is called the insert anomaly. It happens when we try to store data without knowing all the values of the attributes. In this case, the coupon value in the first row doesn't contain any values. So this is the first anomaly. The coupon value can exist or no. The second anomaly is the update anomaly, and it occurs when there are data inconsistencies for redundant data in the table. We can see two columns, product name 1 and product name 2. We try to update the product name 2 from the row 1. This data is redundant in the second row of the table, and we can cause update anomalies with update just one row in the table. This anomaly can cause inconsistencies in the database. And the final anomaly is for deletion, when we try to remove certain data that can cause unintended loss of relevant data. For instance, if we remove the second row, we can lose data about the hat product. So this is the last anomaly for a denormalized database. How to normalize to the third normal form? We need to follow several rules or requirements to fulfill or to normalize this database. We need to follow three rules from the first normal form. The first rule is that every table should contain a primary key. Okay, so let me add a column called ID, which will be type identity primary key. The second rule of the first normal form is that every table column should contain a single value. We can see a column called GenderAge, which contains two values, the gender and the age. So to follow this rule, we need to split this column into gender and into age. So let me add a new column called age of type int. I'll move this VARCHAR to the gender. And the third rule for the first normal form is there shouldn't be groups between the table columns. We can see two groups, product name 1 and product name 2. So we are violating the first normal form. How to solve this problem? By adding a new table called product, which will contain the ID and the name of the product. And then applying table relationships, we bind the customer, which will contain one or many products. I will not create a foreign key or any query relationship here. It's not the goal of this demo. So I'll keep it simple to create the table product and to remove these two groups of product names, and the customer has one or more products as relationship. We are in the first normal form. We are normalize a database. We are able to follow the second normal form that must satisfy the first normal form with the three applied rules, and an additional rule that says that every non-key attribute on the table should be associated with the primary key. Okay, and we can see in the customer table that the coupon column is not directly associated with the custom table with the primary key, that is the customer ID. So how to solve this problem? By creating a new table called coupon, which will contain similar columns from product and ID, and the code of the coupon will be the same type of the coupon column. the customer table and remove it from the customer, and we need to create the respective relationship from customer and the coupon, because probably we need to associate multiple coupons to a single customer. So we are in the second normal form. The goal of this demo is to be in the third normal form, or to transform a database in the third normal form. And to do that, we need to satisfy all the first and second normal forms, but also by adding an additional rule. The rule is that there shouldn't be intra-table dependencies between columns. And if we look carefully in the customer table, we can see that the ZipCode depends on the customer, depends on the primary key, but also depends on the city column. So there are intra-table dependencies in this table. Every single non-key attribute should depend solely on the primary key. This rule is not followed because the ZipCode depends both on the ID and the city columns. How to solve these intra-table dependencies? By adding a new table called zip, and then define the two columns for the code and the city, because the ZipCode is closely related with the city. And by removing intra-table dependencies from the database, we now are in the third normal form. We've normalized the normalized database in the third normal form, and we detect those anomalies in a denormalized database. What are the benefits of normalization? Consistency. It minimizes data redundancy and the potential for inconsistencies and errors. Integrity. It facilitates database management through relational integrity. Data persistence. It stores data effectively and efficiently. Design. It builds a well-organized database structure. And the drawbacks. Complexity. Normalization to higher normal forms, 4 or 5, can be time-consuming and difficult to satisfy. Joins. Several tables can produce relationships that are interrelated using joins. Flexibility. Data is organized in a specific form, which can limit the flexibility of a database. If you want to learn more, don't forget to subscribe. May the code be with you.